Nice, we have another easy problem asked. Okay, so the problem here just asks us to find a polynomial function, or it asks us how do we find the polynomial function that has zeros, 0, 1, or 0, -2, and -3. Okay, so tell you a little bit about polynomial functions. So polynomial function, let me not tell you about polynomial functions. I feel like I'll tell you about polynomial functions. So first we need to understand what are zeros. So the zeros of polynomial function basically means that when the function crosses the x-axis, this is a zero. And we know that the value of y is 0 because that's when a function crosses the x-axis. So we know these points, this point, over here, they're both zeros because when it crosses and touches the x-axis. In this case, we know that the x is something like, maybe let's just say it's 5 because it is positive. And here we know that the x is probably something like -7 because it is negative over here. And again, the y value is just 0 because that's when the function crosses or touches the x-axis. Perfect. So in this case, we want the find polynomial function that has 0, 0, -2, and -3. So from here, we know that this function actually has, how do you say it? This function here actually would be of the form x minus 5 times x. Or I guess that kind of, let me think about how to explain it. Okay, now let's look at a separate function. Let's just say there's a function of f(x) that equals to x squared minus 1. And we just need to factor it. I'll just do it quickly for you. Once you factor it, that function would be x minus 1 and x plus 1. Now, let's just quickly draw this function. To draw this function, we know that the function would look like this because if the x is positive, that means that it concave up. And we also know, and here, how do we find those two coordinates? We know that it would just be x equals to positive 1 or negative 1 because x minus 1 would equals to 0. That's when the function would equals to 0. And when x minus 1 equals to 0, we have x minus 1 equals 0, and 0 which is equals to the x of which is equals to 1. So x would equals to 0. And again, let's do the other one. When it's x plus 1 equals to 0, that's the other place that the function is going to equal to 0. And here we have the x value as -1 when the function is equals to 0. So yeah, this is the example that's different of how about the two x-intercepts of when the function intercepts the x-axis. Okay, so similarly, for our current question, how do we find a polynomial function that has those 3 zeros? All we gotta do is, let's just say our function for this solution is g of x. All we gotta do is that we need to find a function that has zeros -2 and -3. We know from here that when x is equals to -2, so when x is equals to -2, in order to find a 0, we need to plus 2 on the both sides, so we have x plus 2 equals 0. So we know one of the terms of our function is x plus 2. Similarly, when x equals to -3, we just need to plus 3 on both sides, so the other one function is equals to x plus 3. Now, our third 0 is just 0. How do you do that? It's actually very similar. So we know that we have x equals 0, and when x equals 0, we just need to put x here for our x equals to 0. So yeah, this is our polynomial function that we need to find. We have x plus 2 times x plus 3 times x. And this is our answer. So we can just leave it like this. But we could also simplify our function even further. So let's just do that. To simplify it, we just need to times each term by the other. For those kind of questions, we would always have 4 terms. It will be the x times x, which is x squared. Next, x times 3, which is 3x. Next, 2 times x, which is 2x. And we have 2 times 3, which is, we just have these 2 functions multiplied together. And then we collect like terms. So we collect the 3x and the 2 plus 5x plus 6. And then we just have multiply the entire x, which will be x cubed plus 5x squared plus, and that is our function, our polynomial function that has the 0. And this would be our final solution over here. Perfect. Nice. Now let's see what is the sample solution. The sample solution here, yep, they gave a brief explanation. But they just give you the expression without really explaining it too much. I guess you can also do that. That would also be a way to do it. You just use the expression. But this explanation actually helps you to understand the why of why this expression exists and why are you using this expression to find a polynomial function. Cool? Okay, their solution is correct. It's the same as ours. Amazing. Amazing. Excellent solution. Excellent solution. And the solution is correct. Now let's move on to our problem number